So I think you know that a quadratic is just a polynomial that has x squared. We call it a parabola. We've already mentioned that word. The parent function, I just wanted you to write it down one more time so that you've practiced graphing the parent function. So see, if you do the retake next week for the quiz, you'll have that much more quadratic knowledge and transformation practice. So your skill level should go up as the unit continues. So we know that our vertex is at 0, 0, 1, 1 on either side, and then 2, 4. 1, 2, 3, 4, because 2 squared is 4, and then 3, 9, because 3 squared is 9. So 1, 1, 2, 4, 3, 9. I guess I should write 0, 0 is my vertex. And then it's a smooth curve, and it continues forever going up. So you have to know the quadratic. And I'd also love for you to write down the domain and range for a quadratic, just so we have it again, even though it's on our parent function page. At least we've got this other resource page emphasizing domain and range. What's the domain of a quadratic function? Infinity, or all real numbers, is a better way to say it. If you're going to write infinity, you need to write negative infinity to positive infinity with parentheses. Or you could just write all real numbers. So that's my domain. And then my range is what? Y is greater than or equal to 0, like that. You with me? All right, so that's the parent function that we're going to use for every other transformation. So the first one is standard form. I'm starting with the more challenging first, because I think when we get to vertex form, you'll be like, oh, vertex form's easier. Wish I had vertex form all the time. So y equals ax squared plus bx plus c. That's called standard form. And to graph it in standard form, there's kind of some steps that you can go through. I call it the ABCs, but I don't know how you learned it in the past. First of all, that A value. What does A tell you in this equation? So A tells you the concavity. So in our equation here, A is telling you that the graph is going to be concave up, and it's going to be steeper, right? So I know that I'm going to be drawing a parabola that looks like that from this two, right? A, B, and C. Do you remember that, hopefully? Then number 2, I'm going to find the vertex. Negative b over 2a is that equation to find the vertex that you need to have memorized. It's an important math fact for all quadratics. Does that ring a bell, I hope? So when you do negative b over 2a in this equation, I would get positive 8, right? Because negative, negative 8. And then 2 times a in this equation would be 2 times 2, which is 4. So that gives you the x value of your vertex. How do you find the y value of your vertex? If you have an x, what can you do? How do I find the y value from an equation? Use the x to do what? In the equation, right? So I'm going to do 2 times 2 squared minus 8 times 2 plus 6. So you try using order of operations and see if you can come up with the right y value. See if we can get the same answer. Did someone get it? Negative 2. This should give you positive 8, right? 2 times 4 is 8. You're subtracting off 16, so that gives you negative 8 so far, and then you're adding 6. All right, so if 2 comma negative 2 is my vertex, I plot that there. There's one other piece. Do you remember what the C value tells you? Yeah, it tells you the y-intercept is at 0, 6. So you could also plot the y-intercept if you want. 2, 3, 4, 5, 6. And then it has a symmetric, like, partner point kind of over that axis of symmetry. Remember we called this the axis of symmetry for a quadratic, a vertical line through the vertex. And then let's see, we have one more point that we need to put in. It's stretched by a factor of 2. So when I go over 1, I need to go up 2 units. And then when I go over 2, it was up 8. And that hits those points that I already graphed by my y-intercept. So the y-intercept just helps you check that you're doing things correctly. So that's a lot of information, but if you already know the parent function, really the only thing that you've got to memorize if you've kind of forgotten is that negative b over 2a. And we're going to be doing some practice with that between now and your test. And then this will be a resource page, you know, that on your final exam, the second half of your final exam, you'll have this resource page to go back to, because it is a lot of information after you've done 6 units. Are you with me on standard form? All right, so I put vertex form on the back page. This is our resource, and then we'll do the guided practice next class. But vertex form, y equals a x minus h squared plus k, which looks horrible. You're not going to have to remember a, h, and k, just what they do. So A, again, is your concavity and your stretch. Just like the A in standard form, they keep the variable the same to help you. So A is A. H and K have different roles. H is your left and right, because that's a transformation rule. K is your up or down, because that's also that transformation rule that we learned for our quiz. So this part you should actually already be able to do because you already took a quiz on transformation rules. So what would our first example do? Where do I go? Right, left, up, down. Yep. Right 1 and up 3 for the vertex. So see how you're practicing the transformation rule again. What is this A value? I don't see any number written here. So it's 1. So it's the parent function. It hasn't been flipped or stretched. So I can just graph 1, 1, and 2, 4 from the vertex, over 1 up 1, over 2 up 1, 2, 3, 4 from the vertex. You cannot double check the y-intercept the same way. So if you notice, my y-intercept is at 1, 2, 3, 4. There's no 4 in this equation. So vertex form tells you the vertex. It doesn't tell you where the y-intercept is. You have to plug in 0 for x. And see how if you plug in 0 for x, you actually do get 4 as your output. So you can still find the y-intercept. It's just you don't have a c value. It's a different type. All right, what about that second example? Where am I moving this time? Up, down, left, right. So I'm only moving left 1. So that means that my y value is going to stay on the x-axis at 0. There's my vertex. So where do I go once I have my vertex? I have to look at the a value, and what does that tell me? I'm steeper by 2, and what else is different? What other transformation? It's a negative 2, so I have to flip over the x-axis concave down. So if I'm stretching that parent function, instead of 1, 1, I'm going to go over 1 and down, 2. I said it and then didn't do it. All right, and then normally I would go 2, 4. 2 squared is 4. So this time I'm going to go 2 what? 8, twice as far, and I'm still going down. So 2, 8 from the vertex. You always count from the vertex. You don't count from the first set of points. So that's from the vertex over 2 down 8. That's a mistake that I feel like was made a lot in Algebra 2. They were counting 8 units from the next set of points, and it's always starting back from the vertex. So that's it. Did that one seem hopefully more familiar because we just did transformation rules? It's stemming right from that. And then last but not least, My least favorite is intercept form, but it's also factored form. So you're going to practice factored form when we do intercepts. And that one is y equals a x minus p x minus q. I guess it's not my least favorite. I tend towards standard form and vertex form the most. And then here's intercept form. It's just factored form. And because it's in factored form, it tells you the x-intercepts are p, comma, 0 and q, comma, 0. If you plug in p minus p is 0. It gives you an x-intercept. And the vertex is halfway between x-intercepts is the x value. So I'm going to show you what that means. Maybe I'll do the first example and you can try the last example to wrap up the week. All right, if x plus 2 is a factor, what has to be an x-intercept? What do I plug in for x to get 0? Do you remember this, the zero product property? We're going to review it next week. -2 is therefore one of my x-intercepts, and I plot it on the x-axis. This is called intercept form because you're going to get your x-intercepts. Just like vertex form, you get your vertex. Standard form, they don't give you anything. All right, what about the other x-intercept? What do I plug in for x here? To get 0, I would plug in +4. So 1, 2, 3, 4 is my other x-intercept. All right, so this is going to be a parabola. It's going up because this is +1/2. It's going up. How do I find the vertex? So it says the vertex is halfway between the x-intercepts. What's halfway between the x-intercepts? +1. My vertex is at 1, comma something. If I have an x value, how do I find the y value? Plug it in. All right, so plug it in and see what you get. 1/2 times 3 well, if you plug in 1 plus 2, you'd have 3. And then what do we have? 1 minus 4, -3. Isn't it 1/2 times 3 times -3? Is that -4.5? Oh, that was not a very nice vertex. All right, so we're just going to plot. Is that right? Am I with you? Okay. 1, 2, 3, 4.5. So I'm not going to find all the other points because I started on a fraction or decimal. So at least I've got the vertex and the 2 intercepts. Because then I would have to go like over 1 up 1/2. I guess that's not too bad because then you would hit right here, right? And then you'd have to go over, that's why over 3 up 4.5, that's the x-intercepts. But that's good enough. All right, you do the last one. Find your 2 x-intercepts, see if you can find the vertex and graph it. I'll give you like a minute or two to try it on your own, and then I'm just going to put mine